this particular study, we were trying to understand this basic question of what does it mean for an object to be soft? If you look at all the different types of technologies out there for our other senses, if you look at, for example, your sense of sight or your sense of hearing, there's a lot of technologies to recreate stimuli. So for example, if I want to see something, I can just turn on television. Or if I want to hear something in virtual reality, I can just turn on a pair of speakers. This type of technology doesn't exist for the sense of touch. Some of our goals are to understand why there's this technological gap and what can we do to build new materials, build new devices that can address the sense of touch. So we're really trying to figure out how can we design for the sense of softness and how can we use this information to build new devices that are more convincing. We're designing very specific samples that behave under a very predictable way as people touch them. By creating a selection of these slabs, we can have human subjects perform two types of psychophysical tests or tasks on these slabs. The first test is called a two alternative force choice test. We have multiple slabs and we're just handing them two at a time. We say, which one do you think is softer? So you have to pick one or the other. We do this multiple times for all different combinations. And eventually we're able to back out, well, they must have been using this type of material property to make their judgment. The second task is a magnitude estimation, which is a fancy way of saying kind of a number line. So if you put the hardest on one side and the softest on the other, and you space out your samples saying, well, the spacing is kind of important. So a 3 and a 4 are more similar than a 6 and a 9. So this is a very practical test. It tells us, well, if you want to make something feel twice as soft or 3 times as soft, how much do you need to change the material properties to achieve this goal? So because we know these materials, how smooth they are, how soft they are, at least from an engineering perspective, we can take human responses from our subject testing and back out what they must have felt, what kind of properties that they must have been picking up on. And then from there, build a more general relationship for how humans perceive softness. If we can develop these types of tools that can interface with the sense of touch, then we can also understand basic mechanisms about how touch works and answer other questions fundamentally about how we perceive the world.